This video is going to show how to create and simulate a Ferrite bead spice model in PSpice Designer. When designing modules such as amplifiers, power supplies, and digital signal processors, it's important not only to keep noise out of the circuit output, but also to prevent noise from feeding back into the input. Ferrite beads are built like inductors but have a nonlinear impedance curve, making them ideal for noise isolation. Start by opening the provided design in PSpice Designer. First, let's have a look at what this power supply circuit does without a Ferrite bead. For that, we need to create a simulation. Select PSpice New Simulation Profile from the menu. The new simulation window opens. Enter the name SMPS Trans and click Create. If the Simulation Manager Product Choices window opens, select the appropriate license and click OK. The Simulation Settings window opens. Here you can define the type of analysis, analysis settings, and configuration files. For this example, enter 10 milliseconds for the run-to time and 50 nanoseconds for the maximum step size. Leave the other settings as the defaults and click OK to create the simulation profile. Probes must be placed to ensure the correct data is displayed when the simulation is run. Select the voltage level marker button from the toolbar to place a voltage probe. Click to place a probe on the VN net, then right-click and select End Mode. We are now ready to run the simulation. Select PSpice Run from the menu to start the simulation. The PSpice AD window opens to show the simulation results. The input voltage is littered with voltage spikes, which could easily introduce noise or damage other components. We'll correct this with a Ferrite bead. Close the PSpice AD window. Since Ferrite beads have nonlinear impedance behavior, their models are typically created from datasheet plots. Open the provided datasheet in your preferred PDF viewer. Scroll to the second page and view the impedance characteristic curve. This curve will be used as a reference to create a Ferrite bead spice model. Preliminary spice code for a Ferrite bead is included as ferritebead.lib. Open this file in your preferred text editor. The code defines a subcircuit titled Bead with two nodes. The gain between the two nodes is defined as a frequency table with the frequency keyword. There is also a shunt impedance across the nodes defined by RBead. To define the component behavior across a range of frequencies, add the provided frequency expressions to the code. Each expression is formatted with three arguments: the frequency, the gain at that frequency, and the phase shift at that frequency. Since the gain at each frequency is defined as the current through the model over the voltage, each gain value can be calculated by reciprocating the impedance at that frequency and finding the decibel value. When finished, save and close the text file. Now let's place the model in our circuit. Back in Capture, select File, New, Library from the menu. A new library is added to the project manager. Right-click the library and select Save As to name it. Browse to the working directory and enter a name for the library. We'll call ours ferritebead.olb. Click Save to save the library. Now we need to create a component to place. Right-click the library and select New Part. The New Part Properties window opens. Enter Bead for the name and L for the reference prefix. Leave the other settings as the defaults and click OK. The Part Editor tab opens automatically. We'll start by adjusting the working canvas size. In the Part Editor tab, adjust the outline to be 5 grid spaces wide by 2 spaces high. Select Place Rectangle from the menu to place the outline rectangle. Click to draw a rectangle around the entire outline and click again to finish. Let's add pins to our Ferrite bead component. Select Place Pin from the menu. The Place Pin window opens. Here you can define the pin name, number, function, and symbol. Enter 1 for the pin name and number and set the shape to short. Click OK to place the pins. Click to place a pin on each end of the part. The pin name and number are incremented automatically. When finished, right-click and select End Mode. Now we need to associate our spice code with this component. Select Associate PSpice Model from the Properties panel. A prompt appears that the symbol has been modified and must be saved before proceeding. Click Yes. The Model Import wizard opens. First, we need to match the spice model to the component. Select the ellipsis to load in a model. Browse to the Ferrite bead.lib file and select it. The matching model is selected automatically. Click Next to advance to the next screen. Here we can map the pins defined on the component with the pins defined in the spice model. Select the appropriate symbol pin from the drop-down for each row to match the model terminal column. When finished, select Finish to associate the model. Close the Part Editor tab. We can now place the part in the schematic. Select Place Part from the menu. The Place Part panel opens with the new library already added. Select the library and choose Bead from the part list. The PSpice symbol at the bottom of the panel indicates that a PSpice model is attached. Click Place Part and click to place the bead between V1 and M1. Right-click and select End Mode. The wire segment between the bead endpoints will remain intact, shorting the bead. To remove the wire segment, select it and press Delete on the keyboard. Before we simulate the circuit with the bead, we need to link the spice code defined earlier. Select PSpice Edit Simulation Profile from the menu. Select Configuration Files from the table on the left. Here you can define any relevant files to be included in the simulation. Select Library under Category to define included library files. Select Browse, then select the Ferrite bead.lib file we edited earlier. Click Open. Select Add to Design to add the code to the configured files list. The code has been added to the simulation for the current design. Click OK to save the settings and close the window. We're now ready to run the updated simulation. Select PSpice Run from the menu. When the simulation finishes, the PSpice AD window opens. At first glance, the noise looks like it has worsened. However, the higher noise amplitude is due to the plot being zoomed in. To fix this, select Plot Axis Settings from the menu. Select the Y-axis tab to adjust Y-axis settings. Under Data Range, select User Defined and enter 0 volts for the minimum and 6 volts for the maximum. Click OK to save the settings and close the window. Now you can view the plotted results. The noise has been filtered out by the Ferrite bead and the SMPS input holds steady around 5 volts. Quickly create a Ferrite bead spice model based on datasheet parameters to model accurate circuit behavior and ensure proper noise isolation with PSpice. For more tutorials, visit us at resources.ema-eva.com and don't forget to like and subscribe to our YouTube channel.